I suck at ATS. What you're looking at right now is a program that I thought might show off dot notation a little bit better, since the last video focused mostly on the limitations. I think if you're going to use it in an ATS program, this is how you'd use it today. So you create an object, a linear object that you can modify in a safe manner, and then you consume it at the end. So yeah, you check its status, you move him east, north, east, and then he dies. So the status output down here, and then the final output. This is 1 north, and then 2 east. And he starved 3 times. So he's like, his hunger level is 3. So that object is just a tuple. It has a name, location, and a hunger level. And then in order to make it a linear object, I wrap it in a data v type. And I've used some other languages like Mercury, which has like uniqueness types, but doesn't really have uniqueness types. It just sort of has them for I/O. So like Mercury, in order to have Mercury is a pure functional language. So you do I, but it still has the ability to do I/O. And the way it makes that work is by it takes the entire state of the world as an argument, and then singly threads that state through the program until it returns to the world. So the idea is if you don't duplicate the entire state of the world, like if it's linear, then it's safe to mutate it in place. That's actually an optimization. So and this is an optimization though that you don't benefit from in Mercury for like things like arrays. Like they have like some things that sort of make it work. It's a little bit weird, the state of uniqueness in Mercury. But the point is, like, if you have an array, what you'd like to do is do the same sort of thing, like singly thread it through your program so you can mutate it in a safe manner, and in a pure manner, without causing any problems. But Mercury can't really do that. In ATS, you can do that. You can take any kind of random data and you can make it linear, and then you can mutate it just fine. So here's where I'm creating it. So in the whole video, I showed creating a tuple by creating a hull, but of course you don't have to do that. This is the way you'd probably do this normally. Then mob die. I don't have a bang, so I'm consuming the linear object. And here I have a tilde showing that again you're deconstructing this. You're freeing the memory load associated with this. And then I pattern match on the internal object on the tuple. Now with moving, I have this @ sign. So I match the data in the linear object. Do pattern matching with the @ sign. It sort of opens it up for mutation. And since you open up for mutation, you have to do that magic fold thing in order to close it off. So say, at this point, after this point, it's a consistent object, and you can't mutate it anymore at that point. So I open up for mutation, doing pattern match on the object inside. I do more pattern matching to pull out the coordinates, and then I assign the coordinates with based on whether you're going north or whatever direction you're going. So if you go north, I give it, okay, you have your old x and then your y minus 1. I notice that this is all in where, so this is basically this would be the same thing as like let and all of this stuff. In end. It's the same thing. It just looks a little bit neater. And mob status, again, not consuming it. I'm also not mutating it. I'm not deconstructing it. I just do normal pattern matching to get a few values out of it. I actually get everything out of the internal object, and then I print them out. Mob starve, and @ to open up for mutation, and I mutate it, and then I say, okay, we're done mutating it. And in this case, I'm actually I'm deconstructing a list, a linear list of mob objects. All right, and then I do some overloads. One thing you notice here is I don't have a symmeter. I don't have this line. This is apparently completely unnecessary. You don't need it. It'll just create a dot move symbol when you do an overload. So I have overloads to make all these dot notations work, and I have 2 on die for a list of instead of just a single one. All right. So I said this video is not just to show off dot notation. I just wanted to start with that. What I really want to do in this video is show off more advanced usage of hulls. So previously we just used it as a way to define define tuples, which is, why would you do that? This is just fine. But the more advanced usage of hulls, the reason you'd actually use them is because you can pass them around. But particularly, you can pass them to yourself. So we're going to implement the spawns function, which takes a name and then takes a list of coordinates, and then it returns a list of mobs, a list of orcs that are located in each of these locations. And then I don't actually do anything with them except kill them at the end. All right, so that's this function. And this is actually, so if you're going to use hulls with linear lists like I am here, then you need to satisfy a constraint that linear lists have. So linear lists, even though it looks like a capital L, this is a type def. So it's like type def list vt is it's actually, I'm saying actually of some type. Okay, so I'm actually saying that there's an n, it's a natural number. And also it's greater than or equal to 0, even though Nat already says that. So just say int, okay. And I have a list vt of a, whatever type it is, and n. So this is a capital L. The capital L is a convenience type def. It says, but I don't really care how long the list is. I just want to work on a list. And normally this convenience is all you need. You just capitalize your L's, and you don't worry about how long your lists are, and you can do all your functions. But if you work with hulls, then it kind of breaks down, and now you definitely do need to be very clear about how long everything is, and how long things will be. Otherwise, it fails a constraint when it tries to create the list. So if you want to see that for yourself, just go ahead and do what I'm doing here, but keep the capital L lists and don't worry about adding ints and setting constraints for them or anything like that. Just do it like this, and you'll run into the problem and be really, really confusing for you. However, another way to avoid that problem is just to create your own data type, your own linear list with data v type. My list vt equals give it an arg, of course. Want a list of something. There. If you do that, then you don't have a length, and you don't have any constraints on it, and you don't have to satisfy any constraints. So you can pretty much just go in and say my list vt, and that'll work very, very easily for you. You'll be able to do hulls without any kind of problems. But it's not much more effort to satisfy this constraint. It's just kind of surprising. Why do I have to do this? And why isn't this satisfied? It's kind of strange to see that. Anyway, so we're going to say n, because the thing is, we have a list of locations, and we're creating a list of mobs, and those lists have the same length. So we're going to share that throughout. Wrong one. Okay. So it happens that these lists are the same length. They will be the same length. Res, just call it res. All right. So hulls, it's similar to before. You say create a var, say res, it's a pointer of some kind, and create a loop where the loop is going to. Okay, I'll just do it. And you can't reuse that. This loop right here it's a completely separate function, even though it's internal. It doesn't inherit anything like names of parameters or constraint variables like this. It's its own thing, so you have to duplicate that. Lowercase still right here. Okay. So my list is a void function. It returns void. It takes a name, it takes a list of coordinates, and it takes a hole, or it takes a reference to a pointer, which is going to turn into a linear list of mobs. And all these lists are the same. The lists are the same length. So this is going to be the case everywhere throughout the list. So when it starts out, it'll have 3 coordinates, and then when it recurs, it'll have 2 coordinates. And at every point, the list that the pointer that I'm updating is going to be that same length. See, that'll be a little bit more clear as I go. All right, so and again, you can create defines to make this a little bit easier. The same thing if you're doing like mylist something, like mylist vt nil sounds like really verbose, but just do define nil wherever you're doing that, and it'll be fine. And you can even do this locally to a module. It's fine. All right, so list vt nil. So locus in this case is empty. Okay, well then the pointer is also going to be empty now. And then what I'm actually doing here is I'm assigning to the hole that's the end of the list that I'm creating. I'm saying, okay, the end of the list is now actually nil, rather than a cons to a continuation of the list. Let's say look. I'm going to use let syntax, but I'm just going to say this returns nothing where, because it just happens that everything I'm going to do now is going to be a binding rather than like something for side effecting. Something for a side effect. All right. So val, I'm going to assign res now. We can say, okay, if loc is a cons of some kind, then okay, the list we're creating is also going to be a cons. And it's going to be a cons of spawn, of the name. Spawn is this function we created above to create it. So it takes a name and a location, and then it creates the mob. So I'm just going to pass the loc right to that. And then we're going to create that with a hole. So we're creating a list, we're creating a cons list, but we don't know yet what the next part is going to be. And then, of course, we want to match against that. We'll go ahead and put in that, since we're using holes here, we're going to have to fix the type afterwards. And note that this doesn't exist at runtime. This line has no runtime effect whatsoever. So in particular, it doesn't cause this previous line to fail. Or it doesn't cause it to be a non-tail call. So I'm also saying loop name rest with a hole. So yeah. So I'm looping back over the remainder of the locations, and I'm giving it the hole so it can assign the remainder of the list that I'm building. And this is a tail call, and it's to go to and the compiled C. It's fine, even though there appears to be something afterwards. Okay, so that may the other thing again, if you create your own type, you don't have to do this. But if you're doing it with VT, if you're using the built-in type, then you want to satisfy this constraint. So again, list VT, it takes 2 arguments, 2 sorts arguments, I think. Anyway. Well, I'll talk about that later. The thing I was just thinking about. Okay, so list VT, it takes 2 arguments. You have a chord. In this case, the first argument is a chord, just a tuple of x and y, a tuple of 2 ints, coordinates. And the second argument is the length of the list. So we can, when you use a cons, we can say what kind of list we're creating. So ... just figure it out. You know what it is. Just go ahead and infer what the actual first argument is. But for the length, we need to say, okay, what it actually is, and it's in. And this is the same in as this one. So saying, if this list is of length 2, so let's say that this list is of length 2, so it's not going to match this. It's going to match this. We'll take the first one off, and then when you do this cons, this is going to be a list of length 2 as well. The first one is is going to use the location that we took for the first part of the list, and the remainder is going to be the result of looping back, the result of recursion through this. So, all right, I believe that works. Let's see if it actually works. No, it doesn't. Looks like a typo. Line 54. What? Oh, yeah. This is this equal sign here. It should be a colon. That's the error. Fucking hell. And then you're complaining about other stuff. 55. Oh, yeah, I still have to say that it equals something. And what it equals is the rest of that line. The case expression is what it equals. Okay. Yeah, this is like an optimal where you'd have like a typo, or you'd say let in instead of let, and it'll just say syntax error and not tell you anything. Like it's this isn't really like a fundamental problem with the language. It's something that just needs to be improved over time. Error messages in general, and of course, it's something that hits me because I suck at ATS. But you know, once you like syntax is something like the basic syntax of the language is something people should be able to get right. So anyway, let's turn this back how it was. So I like that. Not nothing but res. No, wrong. All right, so we have initial status from Bob, and then Bob moves around, starves a bit, and then he dies. And then all the orcs die where they stood without any moving or getting hungry or anything like that. So, with just except for the just ignore that long break where I had a problem because I got like basic syntax of the language wrong. And I just say this is how you create a list, and this is how you create a list with holes. The advantage is it's basically a for loop in C. If you watch that Deech video, like this is how it works out. You don't have to create it backwards and then reverse it or do anything like that. It also it makes sense. I mean, like you say, I'm gonna create a list, and I know it's gonna have at least one element. So I start with the cons, but I don't know what the rest of the list is yet. So I just have a hole there, and then you go through and you pass the hole as a pointer, and eventually define the hole, and it becomes the rest of the list, or nil. And that's basically the same as doing something like list vt cons, spawn name lock, and then doing the loop that returns the rest of it. It's the same, but this builds in the stack and takes up more memory. Right? It's just not as efficient. It doesn't work in like fixed memory like this does. So this doesn't increase the stack any, doesn't allocate any memory, and it doesn't do any weird stuff. It's as efficient as you can get creating a list, and it's fairly easy. Except for having to put all these ints and saying exactly how long everything is. But that's kind of like you want to do that anyway. It's just that initially, like you want to be lazy and be like make some rough code that's not as clear. And this is a case where unfortunately you're forced to be a little bit more clear than you might want to be initially. But it still works out, and the benefit is you get something more efficient otherwise. And if you don't want to do this, if you still want to be lazy, you also have one option of just doing some code that just doing it the normal way, with like a fold list or something, or looping over and creating using an accumulator and reversing it, or just using the stack and looping here, doing that kind of stuff. So if you want to be lazy, you can just avoid using holes. But if you want to use holes, then the language requires a little bit more of you. Well, list VT requires a little bit more of you because it has the constraint on lengths. That's it. All right. I think that is it for the video as well.